Hello everyone. Today's task is about advanced Mapreduce programming. So the task of today is to understand and run a Mapreduce program with a mapper combined optimization. We're going to do some comparisons between the Mapreduce program with the mapper combiner optimization and one without any optimization. So I suggest you watch this tutorial video before starting the lab tasks. Okay, let's get started. So first one, I'm assuming that you have access the virtual machine, Hadoop virtual machine. So we have to, So first up, you have to make sure that the Hadoop is working well. So if you don't know, you can use some command, Hadoop command to test. Like you can use this command to say whether it's working. Okay, you can see a lot of things, right? So that means the files on the machine. So that means it's working well. Okay, so next step, we're gonna go to our working directory. So you can copy this command. Go to the workspace. Okay, so you can see that the time, the current working the working directory is workspace, right? And next step, we try to copy the lab5 folder from datasets into our current working workspace directory. And in the same time, we want to rename the directory and lab9. Okay, so we can do this by the following command using cp command. Okay. Okay, so you can see that you can use ARS command to say, oh, we got a new directory called lab9. So now we can go to the directory lab9. Okay, you can see that we got some files, text files, documents in this folder, right? So then we want to generate a bigger text document called log.txt, this file, by using cat command. You can see that we combine this document 132, and this one, this document, and this document are four document text document into one. So that's why it's called a large. Actually, this combination of the previous four text documents. Okay, so we can use this command to generate a new text document, which is a combination of the four text document. Okay, you can see that. Yeah, we got this one right. And next up, we will upload this large text document onto Hadoop. Okay, so we can use this put command, right, to upload this document onto Hadoop file system. So you can use this command, right? Yeah. But because I did that before, so I got some warning that log.txt has already existed on Hadoop file system. Okay, so it doesn't matter. So next up, we will do something. Next up, we're gonna generate a new version of word count. Word count you just to use to compute the occurrences of each word in a document, right? So we have seen that before. So we're gonna generate a new word count, new version of word count program with some in-mapper combined optimization. Okay, so to do that, first up we had to but unfortunately we have no right to transfer a document from lab desktop or your own laptop to the head virtual machine. So we had to do that in another way. So what we need to do now is just firstly we had to copy the Java codes for this new document, it's this document. You can see this one is called new word count.txt, including the codes for this one, new word count.java. Okay, so what you need to do now is just go to Moodle page, because this one, the document has been attached on Moodle page. So you can go here, you can go to the Moodle page and find out this new word count.txt. So you can Control A to copy all information, all content of this document, and you can close the document. And then we go back to this one, and to go back to the virtual machine, and then we can input touch new word count.java. Okay, so generate this one. This command is the meaning of this command is to generate a Java program called new word count.java. Okay, this document, but the content is empty for the time being. Okay, so just generate a new empty file called new word count.java. Okay, so we can input here. So you have to make sure that the letter N, W, and C are capital. So because system is key sensitive, so you have to make sure this is correctly. If this is correct, you input correct letters. Okay. Okay, so you can see that we got empty file called new word count.java. Okay, then next up, you can, because we have copied the content of this file, this Java file, so we can use graphical interface to paste the content of code to this empty file. Okay, so we can home, workspace, and left line, and we found out this is empty, right? So we can open with the Genie. It's empty for the time being, right? Then we can paste. We can paste the content here. Okay. Then we can close. Say, okay. So let's go back to the terminal. Yeah. Okay. So for now, we have generate a new word count.java. We're gonna compile and run this command, this program later. Okay. Okay. So now, yeah. Okay. Okay. So now, I think we did this before, right? As we did in the week 4, right? So first step, we had to build a new folder. This is a new folder. Okay. With command mkdir. Okay. Right. Okay. This folder is gonna be used for holding some, classes files when we combine new word count.java, this Java program. Okay. Then this is used to combine the new word count.java, this program. Okay. So we use Java C, this command. Okay, so yeah, it's working. Next step, we try to package the combined app classes, Java classes, into a single jar file. So we can copy the command jar command. Okay, including you should make sure that you have include this space with this dot. Yeah, you should be included in this command. Okay. Okay. Okay, I think it's working well. Next up, okay, so next step, we're gonna run this command, this Java jar file, right? New word count.jar. Okay, this file. And because we use time, so you can see the result is gonna show some results with running time. So this is a command for that purpose. Okay, so compound. Okay, because I might use that before, so maybe I have to change the folder name to holding resource. So maybe I can give any arbitrary string, maybe A, B, C, D. Okay, so for you, maybe because you haven't generated this folder on Hadoop file system before, so you don't have to add more strings. Okay, so let's run this command. Okay, you can see that the Mapreduce program is running. Okay, so you can see that you got a resource, and in the same time, you got some running time information, right? You got 21.474 seconds, right? Okay, so next up, so that means this Java program with optimization is working well. Then we're gonna do some comparisons with some normal previous word count without optimization. Okay, so it's quite because we can of course this word count program gonna be running over the large.txt file we have generated before, right? So we can use this easy way to run the basic word count without program without any optimization. This is the easy way because we have got that before. Okay, so you can use that to type this command. We don't have to compile Java program. We just use that this example jar. Okay. Maybe I have to give some string because I have done that before. Maybe 1, 2, 3. Okay. You don't have to do that because you didn't run that before. You can see this Java program without any optimization is running. You can see that this is running time for this one. It's slightly longer than the first one because our large.txt actually this document is not very large actually. So you can see that the running time just a slight longer than the previous program with optimization. If you're gonna work on, I think you can try to generate a large maybe 100 megabytes documents. I think that in this case it might take a longer time to run for the program without any optimization. Okay, so yeah, so this is the task of today. Okay, so I think at the end I hope you could understand why optimization is working. Yeah, so I think this is can explain why the running time is longer than the previous program with optimization. So this is the task of today. Okay. Thank you for watching. Good luck.